In this video, I'm going to briefly present RBF or radial basis function neural networks and use them to predict the output of an unknown function. RBF neural networks have three layers: the input layer that consists of all inputs, and in this case to a problem; the output layer to predict all outputs of a problem, M in this case; and several hidden layers, each with a different number of nodes, to predict the output values based on the inputs. So here is a simple example that I want to use to demonstrate how an RBF neural network can be trained and used to predict the value of an unknown function, the XOR function in this case. And here's the truth table that I want our network to learn. So let's go to the provided folder in the course website to train and use a simple neural network for this purpose. As you can see, there's only one file here, and it's called main RBF neural network. And we're going to use another package called VT neural network. And this is how the layers for our neural network will be set: 2, 10, 10, and 1, which means we have 2 hidden layers, 2 inputs, and 1 output. So here is how we initiate a neural network with these layers. This is the training data, which is basically the truth table for the XOR. 0, 0 should produce 0, 0, 1 should produce 1. So this is how we train. So we pick a random training data, 1 out of these 4, and then we're going to train our neural network with the input and output. And after 1000 iterations, we're going to see if our neural network is able to predict the XOR function. And this is how we do it. So for each of these 4 training data, we have the X1, which is the actual output, and then we activate our neural network with the input. We run, and then we basically round the number to 1 digit, and then we're going to find the error, and then we're going to print it on the screen. So let's compile the program and see how it works. So to begin, we're going to train our neural network for 1000 iterations. And as you can see, we have quite a high error. For example, in this case, the real input is 0, 0. The real output must be 0, but our neural network predicted as 0.3, and therefore we have 0.3 error. So let's go to 100,000 and let's see if the error would be reduced. And as you can see, we can now correctly predict the value of XOR function. One more try. Now we're going to have less iteration, and as you can see, we're going to have some errors again.